Thank you very much for joining us. This event is the Magnetic Sensor Media Workshop, jointly hosted by NOVOSENSE and Yole Group. Thank you all for being here. Please allow me to introduce today's guests and agenda. We are honored to welcome Pierre-Marie Ricci, Senior Technology and Market Analyst for MEMS and Sensing at the Yole Group, and Mr. Ben Shi, Marketing Director for Magnetic Sensors at NOVOSENSE. Thank you once again for joining us. Today's event consists of 3 sessions. In session 1, Yole Group will share global magnetic sensor trends and growth opportunities in the Chinese market. In session 2, NOVOSENSE will present how applications drive its product portfolio, together with new magnetic sensor product launches. Now, let us begin session 1. Please welcome Pierre-Marie to give his presentation.
Okay. Thank you very much for this workshop. As you said, my name is Pierre-Marie Ricci. I'm Technology and Market Analyst at Yole. I'm part of the MEMS and Sensing team. And today with you, I will show you the global magnetic sensor trends and growth opportunities in the Chinese market. But before to start, I would like to make a little introduction of our company, of the Yole Group, for you to be familiar with. So at Yole, we are a market research and strategy consulting company. We have 3 main core activity on deep synergy. The first one is market and technology activity, where we can provide some forecasts, last trends, and ecosystem analysis. We have the teardown reverse engineering and costing core, where we can provide process and cost analysis of the device that we opened. And the last one is a custom project core, where we can help customer with specific demand, which is not on the 2 first cores, if I can say. The next slide is an overview of our product that we are working on. So of course, we have some reports here, which are released every year or every 2 years, depending on the topic. The data here are on the 5 years forecast, and we have 2 types of reports. We have the market and technology trends analysis reports, and we also have reverse engineering and reverse costing reports to make comparison and analysis of some devices that we can open. We have another product, which are monitors. Monitors are released every quarter, not on all the topics, only on the most versatile one. And this product, we provide the data and the forecast. And the last one, it's teardown tracks. So teardown tracks is when we open some devices or automotive module, we can provide some pictures, detailed PCB, block diagram, interactive, and also bill of materials of everything that we open. So it's kind of reverse engineering analysis. This slide is to show you our expertise, actually. So it's the topics that we are covering. So you can see that we are covering almost all the semiconductor industry, from the memory to display, power electronics, memories, radio frequencies. So we are really covering all the topics on the semiconductor industry. And as I said at the beginning, for myself, I'm part of the sensing and actuating, where I'm covering mainly sensors and MEMS technology. The next part of the presentation here is about the definition and methodology. I wanted just to show you what we define as magnetic sensors in our study and what we define as magnetic sensor for this presentation, for you to be sure to well understand what we are talking about. So about magnetic sensor in our definition for this analysis and for this presentation, we will have this 4 technologies. So the Hall effect, of course. As you know, Hall effect is to detect magnetic field with magnetic layer, which with the Hall effect will detect the magnetic field and will provide a current. And we have all the XMR technology, which are working with magnetoresistance materials, layers, built differently according to these three technologies, but this is the main principle. How does it work? Is with magnetoresistance materials. Of course, we have also other technology for magnetic senses, which are fluxigate, inductive. So in our study, this technology can be used to make some comparison, but they are not included in our data. I mean, when I will show you some forecast and so on, this technology are not included actually in our forecast and in our data for this analysis and for this presentation. We are only taking into account these technologies. So all effect, AMR, GMR, and TMR. So this is about the sensor technology definitions. After that, what we consider also in our data and in this study, it's about the function. So we consider the position sensors to detect position of an object. It could be on an assembly line or something like that. We are considering also e-compass, mainly used in smartphone, wearables, and so on, to detect the north. We can also consider speed sensor to detect the speed of a gear or a wheel. It could be used in automotive, for example. Also current sensors, mainly used in power supply, and also switches and latches that can be used in foldable devices, for example, to detect or open and close when the device is open or closed. And this function, these magnetic sensors can be actually can be used in different applications. The main one is the automotive one, you will see it. And it's becoming more and more interesting in this market thanks to the electrification. That's the new trend that we can see. But we are also seeing it in the consumer devices like smartphone, TWS, tablets, and so on. So that's it for the definitions. And the last slide of this part is about our methodology. So your market forecast model is based on the matching of several sources of information. The main one is the discussion with the player involved in the industry, with interviews, discussion, meetings, and so on. We are also attending some conferences and events to catch information and to meet people in order to consolidate our data and our information. We have also, as I said, our teardown activities where we can show what is inside a magnetic sensor, for example, in order to understand well how does it work. And we have also existing report because, as you know, we are in this market since many years. So we already produce several reports. So we have our existing database and existing data to help us to consolidate our data. And after that, to build our forecast, the data are consolidated with two methodologies. The first one is a top-down approach, where we go from the N system level with the number of sensors per N system. After that, we have the volume. And when we define an ASP for average selling price, we have the revenue. So this is the first part of the analysis. And the second part, the second methodology, is to go from the bottom up, from the ecosystem analysis with the revenue and the volume generated by the players. And after that, we are trying to cross-check these two methodologies to consolidate our data and to provide the most accurate forecasts that we can. So that's it for the presentation of all and the methodology. I think it was really important to spend some time on this point for you to understand well how does it work. Now I will focus on the topic of this workshop, so magnetic sensor market and application. And the first slide is to show you the magnetic sensor forecast by market, actually. So these data are coming from our latest magnetic sensor report that has been released beginning of 2026. So it's really new report. So with this forecast, we can see that the magnetic sensor industry generates $3.3 billion in 2025, and we expect it to generate 4.3 billion in 2031, with a 4.5% CAGR on this forecast period. The automotive market here in orange is the main market, actually, as I said previously. There are some good opportunities that are existing for the car sensorization and with the electrification, where more and more current sensors are needed, for example. And these two opportunities will help this market to grow to $2.5 billion in 2031 with 4.3% CAGR on this forecast period. The second main market is the industrial one here in green. The main needs are coming from infrastructures where current sensors and latches, for example, are needed. But there is also a lot of opportunities with humanoid robots. It's also a good emerging opportunities on this market. We can see that this market generates $776 million in 2025, and we expect it to generate more than $1 billion in 2031 with 6% CAGR on this forecast period. Another market which is also interesting for the magnetic sensing industry is the consumer market. So it's the third main market thanks to the need of e-compass in most of the smartphone and wearable devices. Position sensors are also more and more needed in laptop, tablet, game controller, and foldable devices. And this market generates $554 million in 2025, and we expect it to generate $648 million in 2031. And the last market, which is the smallest one, it's a medical one. It's mainly driven by end system like continuous glucose monitoring. I will talk about it more in detail in this presentation, where we can find magnetic sensors used as switches that are more and more used to power on the end system. And this market is expected to have 8.5% CAGR on this forecast period to reach around $80 million in 2031. So now we'll show you little trends in all these markets. So the first one is the automotive market. So automotive and mobility is probably, as I said, the most dynamic end market for magnetic sensors, because as vehicles shift from mechanical machine to computer on wheels, sensor became absolutely crucial. This will ultimately increase the number of position and present sensor in cars, and we can call that sensorization of the cars because it's a trend in automotive. And as magnetic technology are highly miniaturized and cost-effective, their penetration rate has increased over the years and should continue to do so in the future. Several position sensors are needed. Among others, we have position sensor for windows position, wiper position, door lockings, and in addition to pre-existing magnetic sensors, which are, for example, wheel speed ABS, steering assistance, or active suspension. So there are really new opportunities for position sensors in the automotive market. Still in automotive market, because of growing global environment awareness, we see that the government are pushing car OEM to reduce fuel consumption and to shift their car model toward XEV model. So this is what we call car electrification in our definition of our studies. So this trend will drive also the demand for current sensors. Even though different electric cars exist in terms of powertrains, as you know, you have MHEV, FHEV, PHEV, BEV. I won't go into detail in the definition of these cars, if I can say, of this powertrain, but magnetic sensors, magnetic current sensors can be used in all of them, mainly for DC-AC traction inverter, for example. You can see the star in green is where we have usually magnetic current sensors that are used. So, for example, in DC AC traction inverter, we can use magnetic sensors since current are often in the hundred of amp range, and the magnetic sensor is really suitable for this application. So it's really good opportunity for magnetic technology. However, some other power electronic module like DC, OBC module mainly still make use the conventional shunt technology, especially in hybrid vehicles, where electric power is relatively low. So here, for this kind of applications, the magnetic sensors are not the most suitable. So there is still balance between legacy technology and magnetic sensing in the automotive market. It depends on the application actually, but the opportunities for magnetic sensors are quite important in this domain. And about the automotive market, it's my last slide actually. With the electrification and ADAS trends, we expect to see brake-by-wire and steer-by-wire technology to develop in the next few years. There is a lot of traction in these two applications, but nothing has been deployed yet. I will explain you why just after. And what we can say is this technology will bring several advantages compared to how to say hydraulic systems. So electric system here can bring maintenance reduction. So there is no fluid actually, it's just electrical connection. It's also easier for car manufacturing because you don't have to fill tanks and to control the level of oil. It's also good in terms of platform because you can have platform compatible with several type of car, and it's easier to plug some wires to have the steering system and braking system functional instead of plugging hydraulic cables. So it's easy with electrical connections. And another advantage is for braking systems, so you have less particulate matter which are emitted, particulate matter 10 and 2.5 generated compared to an hydraulic technology. Why? Because with an hydraulic technology, the brake pads are always in contact with the disc, so they are generating particulate matters. With the brake-by-wire, so with electrical system, the brake pad can be just released a little to be not in contact with the disc, so it's also good for the environmental. So there are some opportunity with that, but in terms of safety, there are a lot of redundancies that are needed, which can cost a lot of money. And this is the main reason why this kind of system is not really deployed yet, actually. But with this technology, it's a good opportunities for magnetic sensors because position and speed sensors are needed at the pedal level. Here, you can see the star in green. You need magnetic sensor here at the pedal level, but also at the braking system level. Actually, this is the brake-by-wire evolution that we can see. So at the braking system, you will need also position sensors. So TMR and GMR technology are the best solution for this application. And these trends represent a good opportunity for the magnetic sensor in volume as you can see, several sensors will be needed per car. So we expect to see this steer-by-wire and brake-by-wire system to be implemented in the next few years, which is a good opportunity for magnetic sensing industry. Now, I would like to talk about the industrial market. So I wanted for this market to take an example, which is a good trend. Actually, it's humanoid, and as we know, humanoids, robots need sensors and a lot of sensors. So just to make you a little bit of history, so the humanoid robot is until now actually has been used mainly for manufacturing. And we expect to see the first humanoid, and it's already the case actually, to be used in the industrial market, mainly on assembly line. And we expect to see from 2030 some personal robots that can come into the market. to help us in our daily tasks. So the humanoid robot is one of the current trends, as I said, and several players are trying to propose solution, but it's a complex machine, so a lot of sensors are needed. Sorry. Among others, we can find, of course, everything related to optical sensors, but also inertial sensors here for stabilization and so on, and magnetic position sensors. So this is also a really good opportunity for the magnetic sensing industry, because at every joint, I mean every degree of freedom on the arm or on the legs, we have one or two position sensors that can be used, and the technology, magnetic technologies that can be used could be Hall effect or TMR. In addition to this sensor, current sensors can also be used for power management into the system. Shunt technology can also be used, but magnetic sensor with TMR technology is a really good candidate in terms of size for integration, in terms of power consumption, and also in terms of bandwidth, which allow it to have a fast response time, which is really important in this kind of application. So again, here in the industrial markets, humanoid robots is a good opportunities for magnetic sensors. The next market here is the consumer one. So in the consumer market, end system related to artificial intelligence like AR, VR headsets or smart glasses continue to be good opportunities for magnetic sensors, mainly for e-compass, to gain better data in terms of positioning and head orientation. We have also, of course, smartphone. Smartphones are generating most of the volume for the consumer magnetic sensors. First of all, we have position sensors that can be used for mid to high-end smartphone for OIS of the main camera, actually. OIS for optical image stabilization, just to be sure for you to understand. And position sensor can also be used sometimes for stabilizing periscopes, telephoto, and ultra-wide camera. So you can find a lot of position sensors for this functionality in smartphones. That's good for the volume of magnetic sensors. Meanwhile, we have also e-compass. So e-compass, it's really stable for smartphone because almost 90% of the smartphone are already equipped. So it's a huge volume for magnetic sensors. And also, as we know, there is a growing interest in foldable devices, foldable smartphones. So here it's important to have some switch or position sensor for open-close detection. Another hand system which is important to mention for the consumer market is TWS. There are also some opportunities for TWS. First of all, we have switches here, which are still integrating in the charging cases for lead open close detection. For 3D spatial audio functionality, it could be really interesting to use e-compass to correct the drift from the gyroscope and to provide more accurate head tracking. But as we know, it's still a challenge to integrate the magnetic sensors near to a magnetic field source, which is the microspeakers in the TWS. But maybe this can change in the future with the emerging MEMS microspeaker technology, which here is not a source of magnetic field, so it could be easier to integrate e-compass in TWS in the future. Another emerging application I wanted to talk about in the consumer market is everything related to magnetic sensor in game controller and keyboards for gaming. So here, magnetic sensors are really interesting for improving game performances and providing better control. Hall effect and TMR can be used, and even if the price of such end system are quite high compared to traditional options, there is still a viable market because gamer will not hesitate actually to spend more money in their tools if it enables them to have better performances in game. So there is still a viable market here for this end system in the consumer market. And last market I wanted to talk about, actually, it's a medical one. So players in magnetic sensing industry are also looking to diversify their existing automotive, consumer, and industrial activities. And they are trying actually to explore medical application. Sorry. Among other, one of the main application in the medical market is the continuous glucose monitoring devices, where a power switch with magnetic technology can be used to power on the system. So this technology eliminates the need of mechanical button on the end system and can avoid issues related to moisture and breakage. So as we know, continuous glucose monitoring can provide constant stream of glucose data, thus avoiding frequent finger stip. So it's really interesting for the user, actually. And you can see in this graph that actually the volume of this end system is still growing. For a battery-powered application, like the continuous glucose monitoring, TMR technology for this magnetic switch is really good candidate thanks to its performances and also low power consumption. The size also of this technology is interesting because it's really small end system, so integration is better with this technology. And as you can see, several players are involved in this technology, and some of them are coming from Greater China, of course, including NOVOSENSE. Now I would like to talk about the ecosystem analysis. So this slide is to show you actually the global market share in revenue and in volume of magnetic sensing industry. So these data are coming from our latest report, as I already said, that has been released beginning of 2026. So in terms of revenue, we can see that Allegro Microsystem is the leader in magnetic sensor with 17% of the market. He has a strong presence in automotive segment, combining a broad technology portfolio. The TMR technology has progressed the last few years for Allegro because, as you know, they acquired Crocus technology a few years ago, and Crocus technology main topic was TMR technology. Infineon and TDK are number 2 and number 3 with 13 and 12% market share in revenue, respectively. Infineon's portfolio is mainly oriented on automotive application, while TDK is mainly involved in automotive and consumer. And if we look at the volume, so TDK and AKM remain the leader thanks to the integration of their product, mainly in the consumer segment for OIS and e-compass applications. And we can see that NOVOSENSE here is the fourth player in volume and the first player in Greater China, thanks to its ability to propose several kinds of magnetic sensors in automotive, consumer, and medical application. We can see actually that there is some difference or market share difference between the revenue and the volume, and this can be explained by the fact that ASP can vary between the address segment. Consumer application tend to use cheaper and simpler sensors compared to automotive and industrial, for example, and that can lead this difference between the market share. Still in the ecosystem, so this slide is to show you that the players involved in the magnetic sensing industry are coming from all over the world, actually. Historically, the players were mainly coming from United States with Allegro, also from Europe with Melexis and Infineon, and from Japan with TDK and AKM. But as we know and as we see since few years, several greater Chinese players are more and more involved in this industry, as you can see. Of course, this is the case of NOVOSENSE, with, as we know, it's mainly involved with Hall effect and TMR technology. This slide, actually, this is the last slide of my ecosystem analysis, and this slide is to show you where the players are involved in terms of technology and in terms of targeted market. So we can see that the Hall effect technology here is the most proposed one because several players are involved in all the market. AMR technology is also well represented, as we can see here, but TMR technology, which is the last column here, is becoming more and more represented in all the markets thanks to several acquisitions, as I already said, Crocus Technology by Allegro, but also Sensitech by Sinomax. The greater Chinese ecosystem, as we can see, is really well represented in all the market and all the technology. You can see in purple the greater Chinese company here. And the diverse application landscape and fast-growing customer ecosystem have enabled local players to develop and scale. So that's why this ecosystem is really growing in Greater China. The last part of my presentation is about the technology trends on the magnetic sensing industry. And I wanted to make a focus on current sensing. So indeed, with mega trends, as we know, like data center, thanks to artificial intelligence era, also car electrification, we already talked about it, and humanoid robots in the industrial market. We will need in the near future more and more energy, and the electricity demand will rise. So it's sure for that. And this rise will drive the need for current monitoring to be able to manage the production and the distribution of the electricity and to be more efficient, actually, and to make the grid smarter, so to have a smart grid, if we can say. Several technologies exist for current sensing, but magnetic technology with Hall effect and TMRs are really good candidates for several applications. So it's actually a good opportunity for magnetic integrated current sensor compared to shared in terms of integration, thanks to its smaller size, high current possibility, because with TMR technology, integrated TMR technology, for example, it's easier to have an insulation and it's cheaper compared to do that on the shunt technology. So that's why this integrated current sensor are really interesting for this application, and there is really huge opportunity to have a smarter grid. Here is just to show you actually an analysis that we perform on integrated TMR current sensor from Allegro microsystem. So we can see the architecture of the sensor here. So we have the primary conductor here, we have the sensor here in green, and insulating layer. So it's quite difficult to see in this view, but if you look at the cross section, you have better view of the primary conductor here, the sensor here in green, and the insulating layer, which is here. And about the sensor, which is here in green, we did some pictures and some zoom and some analysis. We managed to analyze and to see the TMR elements that you can see here in detail. So I won't go into detail about it, but it's just to show you what we are capable to do. And this analysis is part of also a report that we released recently, which is TMR-based current sensor comparison 2026. And in this report, you can find analysis of devices from Allegro, of course, but also from NVE or Sinomax. So if you have any question about it, do not hesitate to contact us. The next slide about this technology trend is to show you the comparison between the technology analyzed during our study. So it's a qualitative analysis, not a quantitative one. And we can say a few comments about it, about this technology. So first of all, the Hall effect here in red, we can see that it's the cheapest technology with relatively good performances in several applications. Players such as Melexis, AMS, Osram, which is now Infineon, and NOVOSENSE have mastered this technology and seems to have the most sophisticated Hall effect possible. We have the EMR technology, which is here in orange. AMR technology actually is the cheapest technology of the XMR category. This sensor have relatively high SNR cost ratio. And the main pain point actually for this technology is its instability to sense 360 degrees and its lower temperature stability. We have the GMR technology here in green. GMR technology seems to be mainly used for wheel position sensors. And the main reason why OEM do not choose GMR technology for other function is this lower SNR cost ratio compared to TMR, because TMR here in blue, we can see that it's ultra-sensitive die, meaning less need for amplification stage, and TMR ultra low footprint equate to very low power consumption. But actually, TMR is relatively low immune to stray field, so it's not an advantage here. We know that NOVOSENSE is one of the main players involved in the TMR technology. And last slide about this part, and actually about my presentation, is to show you the maturity of the magnetic sensing technology. So we know that Hall effect here is for a long time the most mature one actually, and the one which has been well developed by the market and well adopted actually by the market thanks to its low cost and enough performances for several applications. We have the AMR and GMR technologies, which are at the same level actually in terms of adoption and maturity. Both have their targeted application. We know that AMR is mainly used for e-compass application in the consumer market, for example, where GMR technology is mainly used in the automotive market for speed sensing application. The TMR sensor is a little bit below, actually. Actually, this technology made a lot of progress last year. It's starting to be more and more mature, but due to its cost, which is still high, performances in some application and low immunity to stress field, its adoption is still a little bit shy, if we can say. That's why it's in the middle of scaling technology and mature technology. Nevertheless, the power consumption and the size of this kind of sensor are really good reason to adopt it. So that's why we expect this technology to be more and more adopted in the next few years. So I think in few years, we will find the TMR technology here in the green part of this graph. And the last actually emerging technology, we have the quantum magnetometer and GHS technology. These technology are both emerging technology. Of course, we follow them, and we will continue to follow them in the future to see if they will be more and more adopted by the market in the next few years. So this is the end of my presentation. So I just made an executive summary. So just to summarize, in this presentation, we saw that the magnetic sensing industry generates $3.3 billion in 2025, and we expect it to generate $5.3 billion in 2031. The most dynamic market for magnetic sensor, as we saw, is the automotive one, thanks to the sensorization of the car and the car electrification, where we need, among other, current sensors, position sensors, and so on. The industrial market is the second main market. The main needs are coming from infrastructure, with current sensors and latches are needed. Also, as we saw, humanoid robots is a really good emerging opportunity in this market. The consumer market is still good also, still good opportunity thanks to the need of e-compass in wearable devices and smartphone. And last one, the medical market. As we see, there are several opportunities also, and among others, we have the continuous glucose monitoring that give those opportunities for TMR technology with a switch. In terms of volume, the three main players are TDK, AKM, and Allegro. And if we look at the top three in Greater China, we can see that NOVOSENSE is number one. So thank you very much for your time, and yeah, that's it for me.
Thank you, Mr. Pierre, for your sharing. It has given us a clearer understanding of the global magnetic sensor market and applications, key players in the ecosystem, as well as technology development trends. As Mr. Pia mentioned, NOVOSENSE's magnetic sensors currently rank fourth globally in terms of shipment volume. Next, Mr. Xia will walk us through NOVOSENSE's magnetic sensor technology and application layout, alongside the launch of a series of new products. Please join me in welcoming Mr. Xi.
Hello, everyone. I am Ben Xi, responsible for sensor marketing at NOVOSENSE. I will present the second part of today's webinar. The theme is NOVOSENSE Magnetic Sensors, a broad product portfolio across diverse technologies and applications. Today's presentation has three parts. The first covers our magnetic sensor business, product portfolio, and technology platforms. The second focuses on our core application markets. The final part introduces our product portfolio and the new product launches. First, according to Yole's latest report, NOVOSENSE, as a representative Chinese magnetic sensor IC supplier, is honored to rank among the global top 5 by shipment volume. We also hold a leading position in the Chinese market. Over the past several years, our cumulative shipments have exceeded 2 billion units. In 2025 alone, annual shipments exceeded 1 billion units, representing substantial business growth. In recent years, as a leading Chinese supplier of magnetic sensor ICs, we have also carried out industry consolidation. In 2024, we fully acquired Magnetic, another Chinese magnetic sensor IC supplier. Following the completion of this integration, we achieved significant sales growth in both 2025 and 2026. This is our product portfolio. Overall, our products fall into 6 categories. The first category is switch. As a Yole expert just mentioned, these are products with relatively simple functions that output logic states, such as high and low levels. We offer a broad range of products in this category, though we support multiple technology directions, including AMR, PMR, and Hall effect products. In terms of product functions, we offer 3-wire and 2-wire interfaces, current output products, dual output and single output products, and 3-axis products. Our portfolio covers virtually all major industry requirements. From an application perspective, we offer automotive products for seats, sunroofs, and pump control, as well as industrial and consumer products for applications such as appliance control and open close detection. The second category is current sensor, one of our fastest growing products in recent years. Our portfolio is divided into 2 directions. The first is integrated current sensor. These products generally measure current on a PCB with measurement ranges of up to plus necessary 400 ampere. The second direction is linear current sensor. These products work with special structures such as magnetic cores or slotted cutting carrying bus bars to measure higher currents. They are used in industrial, automotive, current sensor modules, motor systems, and other applications. The third category is angle sensor. Here again, we support multiple technology directions. For Hall effect products, we offer solutions based on planar Hall technology and products based on 3D Hall technology. They simultaneously sense magnetic field changes along the X, Y, and Z axis and calculate the angle. Another direction is XMR technology. Even before the integration, Magnetic already held a strong market position in magnetic encoders. Following the completion of the integration, we will develop and launch more angle products based on XMR technology. These products serve both automotive and industrial markets. Automotive applications include angle detection for valves and motors. Industrial applications mainly involve angle detection in motion mechanisms, such as motors and variable frequency drives. The fourth category is linear position sensor. Their main target is the consumer market, where applications typically have lower unit prices, but very high volumes, such as gimbals and controllers. Within this series, we also offer automotive-grade products for linear position detection in vehicles, such as seat angle detection. The fifth category is speed sensor. We have developed a complete product series based on AMR technology, compatible with the different protocols used by speed sensors. These products are used on wheels in ABS systems. Each wheel requires 1 or 2 sensors, making this a very large market. The final category is sensor signal conditioning. IC. NOVOSENSE has a long history in this field. We have developed signal tech products since the company was founded. We have deep expertise in the sensing elements of different magnetic sensors, including XMR and Hall. Based on this expertise, we developed targeted products with temperature compensation and linearization functions. This is our magnetic sensor technology platform. As a magnetic sensor IC company from China, NOVOSENSE has a technology portfolio comparable to those of leading international brands. We have built extensive technology reserves in sensing elements, including mature Hall technology, XMR technology, inductive technology, also known as eddy current technology, and fluoroscape technology. Hall effect products are relatively mature. Based on silicon Hall technology, we have launched a wide range of products. For example, using planar Hall technology, where the Hall plate is parallel to the wafer, we have developed the current sensors, angle sensors, and squeeze products. We also add nickel air alloy layers on top of the Hall plate to form magnetic concentrators. Based on this technology, we have launched products that can detect horizontal magnetic fields, including current sensors with U-shaped magnetic fields, and 2D or 3D position sensors. The final Hall direction is vertical Hall technology. We integrate planar Hall and vertical Hall elements into a single product, providing functions similar to magnetic concentrator technology, such as 2D or 3D switches and 3D linear position sensors. Another whole material is gallium arsenide. We have also invested significantly in this technology. Our gallium arsenide-based current sensor is currently being sampled. The second platform is AMR. We have launched many AMR products, especially low-power AMR switches that can be widely used in consumer and industrial markets for applications such as liquid double detection. We have also developed high-precision encoders and wheel speed sensors based on XMR technology. TMR technology offers higher sensitivity than AMR. Based on this technology, we have already launched TMR switches with power consumption as low as the nanoampere level. We will also launch more TMR-based products, including angle sensors and encoders. Under the inductive sensing platform, we have launched an industrial-grade, high-resolution encoder based on inductive technology. The final platform is flux gauge technology. NOVOSENSE has launched a closed-loop flux gauge ASIC for high-precision current measurement. The second part covers our core markets. Here, I will briefly introduce several applications directions: automotive applications, industrial applications, and consumer applications. Magnetic sensors are widely adopted and used in large volumes across all three application areas. In automotive applications, magnetic sensors are used across body systems, thermal management, powertrain, and chassis. In body systems, they generally detect the movement of small mechanisms such as window motors, sunroofs, and tailgates, including the rotational position of motors. These applications mainly use switch products, including single-axis Hall switches, latches, and dual-output products that provide both speed and direction. Body systems also include angle sensing applications. For example, the motion of the windshield wiper may require an angle sensor to transmit the angle signal to the controller. Our angle sensors have achieved strong design wins in applications such as wipers, rotating displays, and headlamp attachment. In thermal management systems, our products are mainly angle sensing ACS4 valve applications, such as electronic thermostat valves, water valves, and the expansion valves. The angle sensor is typically mounted on a valve shaft to detect the valve opening and determine whether the valve is open or closed. Some applications only require simple control and therefore use Hall switches. Next is the powertrain. First are the three core systems of new energy vehicles: the BMS, or battery management system, and the traction motor. Both require very high current measurement. Currents can reach hundreds or even thousands of amperes, which can be measured by linear Hall current sensors. OBCS and compressors also include lower current measurements, such as PFC current sensors. These applications use surface mount integrated current sensors. In the powertrain of conventional combustion vehicles, there are also valve position sensing applications, throttle valves and EGR valves. For example, require angle sensors. The final area is the chassis, where safety requirements are generally more stringent. Traditional small modules, such as seatbelt buckles and brake light switches, use Hall switches with relatively simple functions. The brake light switch deserves particular attention, as it requires very high precision position detection. We use programmable Hall switches to achieve this high precision detection. Larger modules include steering wheel angle sensing, vehicle ride height and active suspension height sensing, and the accelerator and brake pedal sensing. These applications use angle sensors. There are also wheel space sensors, including the AMR wheel space sensors. Chassis subsystems such as EPS can also use Hall angle sensors for motor position detection. Let us look at several examples. The first is the seat system. A single seat can use a large number of sensors. Headrests, mechanical massage functions, and backrests all use Hall switches. For motor position detection, linear position sensors can also be used to detect the backrest angle. Forward and backward seat movement may require detection of the seat track lock, which locks the seat in position. Side airbag deployment can also use a resistor chain for linear position detection. All these applications require numerous Hall switches. For the seatbelt buckle mentioned earlier, all two-word Hall switches can be used for buckle detection. The second example is the onboard charger, including the OBC and DC-DC converter. These systems mainly use current sensors. Electric vehicles are primarily electronically controlled, so the key measurements are current and voltage. For PFC current sensing, the typical accuracy requirement is 2%. Isolation from the AC input voltage is also required, so we recommend surface mount current sensors with high acceleration ratings. But another area is the resonant tank, which is the DC-DC section of the OBC. This is also a high voltage application requiring high frequency current measurement. The current frequency can reach 500 kHz, so we provide high bandwidth products to support this application. There is also battery charging current measurement. The battery voltage may range from 400 volts to 800 volts, with currents of 20 to 30 ampere. We provide surface mount Hall current sensors to support this application. The final application is low voltage battery current measurement. A DC-DC converter connects the high voltage battery to the low voltage battery with power ratings above 2000 or 6000 watts. Because the current is relatively high, we provide cordless solutions or compact, low-resistance products for current measurement. The next application is the electric drive system, which provides propulsion for new energy vehicles. Whether the vehicle uses a single or dual e-drive, current sensor modules are generally installed on the motor windings or phase lines for current measurement. We offer all three solution types. The first is the traditional C-core solution, which may account for about 70% of the market. The second solution uses a U-shaped magnetic shield. Some new energy vehicle makers pay particular attention to vehicle vibration and want to avoid structural damage caused by larger and heavier products under vibration. Our U-shaped magnetic shield solution is more compact, but another increasingly popular product direction is the cordless solution. We currently have products in sampling for this approach. The second market is industrial. Magnetic sensors are also widely used in industrial applications, which can be divided into two main areas. The first is PV energy storage and charging, including PV systems, energy storage systems, and charging equipment. These systems use large numbers of current sensors to measure current, especially on the PV side of photovoltaic systems. The second area is industrial control. Industrial control and automation mainly use precision sensing. Current measurement is also needed, but precision sensing demand and volumes are higher. Closed-loop precision control systems, such as servo systems, and closed-loop stepper motor control, require magnetic or optical encoders. As the magnetic encoder market has developed, magnetic sensors have replaced a significant share of optical encoder applications. In addition to magnetic encoders, industrial markets also use inductive proximity switches. We currently have such products in mass production. Other industrial applications such as electric shears and industrial sewing machines, also use magnetic sensors in large volumes. Now let's look at several examples. The first is a PV and energy storage system. Current is measured at every stage, from PV panels to energy storage batteries, and then to the grid connection. On the PV side, high voltage system currents may be measured at 1,100 watts, 1,500 volts, or even 2,000 volts. We offer many wide bodies SOW16 package products for these system applications. The second area is MPPT current measurement, which measures current in the boost circuit. Currents here are relatively high and can reach 100 ampere. Our lower licensing products can support higher continuous currents for MPPT applications. There is also battery side current measurement, which generally requires a high precision product. The battery voltage depends on the system design, such as 48 volts or above 100 volts. Our products with high working voltage ratings are well suited to the high voltage side of the battery. The final stage is the grid side. Regulations require very small DCI or DC current injection to reduce the burden on the grid. We have developed targeted designs for this requirement. Our P-series products are particularly suitable for a C current measurement on the grid side. The second example is the servo system, which is widely used on industrial production lines. A magnet is generally installed at the motor shaft end or end cover, together with an on-axis encoder for rotational position detection. In addition to rotational angle detection, we offer low-power TMR switches for absolute position detection. They prevent the position from being lost if the motor continues rotating due to inertia after power off. A small battery is used to retain a position state on the motor control board. We also provide current measurement, such as high-side current sensing and phase current sensing. Magnetic sensors are also widely used in consumer markets. White goods, for example, require motor speed sensing and current measurement, such as PFC current sensing in air conditioner compressors and current sensing in dishwashers. Magnetic sensors are also used extensively in small appliances, smart home products, and wearable devices. Consumer electronic products, such as gimbals, joysticks, and game controllers, also use linear position sensors in large volumes. Let us look at several consumer market examples. The first is security cameras and handheld gimbals. Camera rotation and vertical movement use linear position sensors or angle sensors to provide closed-loop position feedback. Each axis in a gimbal, whether rotating or moving vertically, uses linear position sensors. We have achieved strong design wins and a very high market share in this segment. The second example is the robot vacuum, a small household appliance. Wheel speed sensing is required for movement, and our hot switch products can be used. Collision detection may use the movement of a mechanical component to detect contact with a wall or obstacle. These applications require low-power hot switches. The third part covers our product portfolio and new product launches. First is our current sensor portfolio. We have a comprehensive product offering across the entire current sensing field, covering both low and high current measurements, using 200 ampere as a dividing line. The left side shows the market for integrated current sensors. We offer many package types of different sizes, each supporting a different continuous current level, from 30 ampere, 200 ampere. The vertical axis represents the insulation withstand capability. Some products are rated at only 100 volts, while others support 600 volts, 1,550 volts, or even 2,800 volts. This portfolio can cover virtually all onboard current sensing needs in high-voltage systems. The right side covers high current measurement from about 200 ampere up to 2,000 ampere, for which we offer strong solutions. This is the roadmap for our integrated current sensors. Each package, shown on the left, has corresponding product plans. Small packages are mainly used in 12 volts, 24 volts, or 48 volts systems, where current sensing does not require a high withstand voltage. The high voltage products are used in systems such as OBCS and DC-DC converters, including current measurement on 400 volts batteries, and as the AC input The middle section is our high bandwidth product family with bandwidth of 1 megahertz or 2 megahertz. These products are mainly used for fast overcurrent response. We have also launched a high precision product family. Through 3 temperature testing, we can achieve 1% accuracy across the full temperature range. Beyond this, we will also offer gallium arsenide-based solutions. One of the key products launched today is an ultra-wide body current sensor. This is the roadmap for linear current sensors. We have products covering all 3 structures mentioned earlier. The mainstream market currently uses this solution. We ship it in high volumes to major Chinese OEMs and have achieved a strong market share. But we have also launched the NSM2132, a linear Hall current sensor based on gallium arsenide. The middle solution is another product launched today, the NSM2025. It is an iteration of our current generation product with an optimized test program and improved accuracy. The final product is currently attracting strong interest in the electric vehicle market. Every electric vehicle maker is studying this cordless approach. It eliminates the U-shaped magnetic shield or C-shaped magnetic core, achieving excellent cost effectiveness and a very small installation footprint. This is one of the products that we are launching in the current sensing category. Traditional products designed for 1000 V systems may provide a creepage distance of about 8 millimeters. The key advantage of this product is that it extends the creepage and insulation distance from 8 millimeters to 15 millimeters with a basic insulation working voltage of 2,800 volts. Many larger photovoltaic system manufacturers are now launching 2,000 volt systems. This product is well suited to these systems, particularly for PV side current measurement. Its compact size and high cost effectiveness allow it to replace much larger current sensor modules. It is also the first ultra-bodied current sensor of its kind launched in the China market. The second current sensor uses a U-shaped magnetic shield. The shield redirects the magnetic shield horizontally, allowing the IC to be mounted on the main control board. For current measurement in an e-drive system, the product achieves 1.5% error across the full temperature range, fully meeting e-drive system requirements. The next part is our industrial encoder roadmap. We support several product directions. The first is A6 encoder signal conditioning IC. For sensing elements such as AMR and TMR, these ICs amplify, compensate, and condition the signals, then output the required interfaces such as SPI and other protocols. The second direction is Hall products. We offer a series based on planar Hall technology, including all-axis and off-axis products. These products can be used for angle detection in applications such as quadruped robots. The new product introduced today is the NSM350X, an off-axis absolute position sensing IC. The next directions are AMR and TMR products. The MP6835 mentioned earlier achieves a very high resolution of 21 bits. It can effectively replace optical encoders above 17 bits and significantly reduce total system cost. The next direction is the inductive encoder. This product has completed validation and entered mass production. Both the NSM350X and Mount 691 are well suited to robotics applications. This is our automotive angle sensor roadmap. Here again, we develop products based on multiple technologies. We have a mature AMR product with a strong market share in China's automotive chip market. The next direction is 3D Hall technology. The MT6521 is used for low-speed valve position sensing, while other 3D products are under development. These future products will mainly serve shifter and joystick applications. The next direction is planar Hall technology. Here we offer the NSM3219, an automotive ride height sensor with a PSI-5 interface. This is our new angle encoder product. It is also the first of its kind in the Chinese market. It is an off-axis magnetic encoder. The motor shaft passes through the center opening. It is a dual track absolute position sensing IC. Its first key feature is the off-axis architecture, which does not affect motor installation or motor dimensions and can fit around the reducer shaft or motor shaft. The second key feature is high precision angle detection. The product uses dual track coding and a vernier algorithm to achieve very high resolution angle detection that it supports 16, 32, and 64 pole pairs with excellent accuracy, including typical integral nonlinearity of plus or minus 0.3 after simple cell calibration, and typical integral nonlinearity of plus or minus 0.3 cell calibration. The product also supports a range of calibration methods, including simple self-calibration and constant speed self-calibration. The final section covers our switches and latches and our linear position sensor roadmap. As mentioned earlier, some of our XMR switch products offer excellent power consumption performance and are well suited to battery power consumer products. The typical power consumption is at the microampere level. We offer single axis and dual axis products with dual axis devices supporting industrial applications, such as liquid level detection. We also offer a TMR switch with power consumption as low as 200 nanoampere, making it an ultra-low power product. Our broad whole switch, low power, cost-effective consumer products, higher voltage products, such as 24 volts devices for industrial markets, and automotive products rated up to 60 volts. We also offer dual output and 3-axis products. This is our linear position sensor roadmap. We offer many linear position sensors with numerous sub-models representing different sensitivities to match different system designs. Some products have fixed sampling rates and sensitivities, while others provide low power modes with sleep and wake-up functions to reduce power consumption in handheld devices. Some products also support unipolar or bipolar sensing, depending on the system design. A button, for example, may require a unipolar linear sensor, while a slide switch or knob may require a bipolar design. Finally, we offer digital output products, including devices with an I2C interface. The new product introduced today also uses I2C, but supports three-dimensional magnetic field sensing. Here we see the new 3D Hall product. It is a 3-axis linear precision sensor based on 3D Hall technology. A vertical Hall element and planar Hall elements are integrated in one IC, allowing simultaneous output of magnetic flux density along the X, Y, and Z axis. The device also supports on-chip coding calculations for angle computation. By combining the algorithm and sensing axis, the product is well suited to spatial magnetic field detection. For example, a game controller joystick may move through a 360-degree spherical space. The device can calculate the magnetic flux density along the X, Y, and Z axis, or calculate the alpha angle in the XY plane and the beta angle in the XZ plane. For spatial vector computation, the smartwatch clone also requires a highly compact, cost-effective 3-axis sensing solution. We can provide multiple magnetic field detection ranges. That concludes my presentation. Thank you, everyone.
Thank you, Mr. Shai, for your presentation. With a solid technology foundation and product portfolio, NOVOSENSE provides a broad range of solutions for global automotive, industrial, PV, and energy storage and consumer markets. It also responds rapidly to the needs of emerging markets. This strongly validates the trends highlighted by Mr. Viss. In the sensor industry, Chinese companies are beginning to establish a growing presence in the global market. Thank you again to both speakers for their presentations.